Hello, Eric. Welcome to the conference. It was a pleasure to hear your keynote. Very interesting on OpenMP in embedded systems.
Thank you.
Eric is on the compiler team at Texas Instruments, and you discussed several ways how to extend the usage of OpenMP in the embedded systems world.
Yes.
Could you elaborate more on that?
Well, I think that OpenMP has been targeted for high-performance computing in the more traditional supercomputing and desktop environment, and that there's this whole other world of embedded processing that's out there, and that I think there's a way for OpenMP, if we do some of these things, like being able to do an event-driven model, we can adapt OpenMP to work in those types of systems, and then that would bring a whole new set of developers into OpenMP, which I think would be a good thing.
Mm-hmm. So, and also a whole set of new applications. You would see OpenMP in cars, in cell phones, in
I don't
cameras.
know. It's scary, right? Yeah, could have it in a car or something like that. Yeah, but yeah, that's the idea. I mean, I'm sure at some point people were like, "Oh, I can't program these things in C code. I've got to do everything in assembly language." In some sense, it's the same way. You want to take those higher level models because you have to. The complexity of the systems is just increasing, and you need higher level programming models like OpenMP.
Yeah, you mentioned the multiprocessing system on chips, and you would like OpenMP to be able from any device to launch code on any other device,
Right. So I mean, what you're seeing is an integration. You had a lot of different processors in the system, and you're seeing all this collapse onto one chip. You're seeing chips that are specialized for certain activities, but what we need is a programming model that can deal with that, because today the model is very piecemeal and contained for each processor, and you want to have something that's more holistic, and that's what I'm hoping we could do with the accelerator model, is adapt it to be a heterogeneous model.
So continue extending the accelerator model. I saw you had an example with ARM, GPUs, Keystone, all different type of devices, all one chip.
Yeah, like one chip is just there for real hard real time signal processor chip for math, hardcore math, graphics with the GPU, an ARM running Linux, but we want a holistic programming model that can comprehend all of that.
Yeah. Also, quite an interesting comment you made on the goal of real time is not so much to be as fast as possible, but just to meet the deadline, that the code is ready, the result of the code is ready when it's needed.
Right. Yeah. Well, so often in OpenMP we talk about performance. We talk about high performance, getting things done as quickly as possible, but that's not always the most important thing. It often is in embedded systems, but not when you're just dealing with a real-time constraint. You just want to make sure that your process or your task is complete before a deadline. Mm-hmm. Doing it faster than the deadline's really not helping you in any way. If you could slow it down, maybe use less power and still meet your deadline, that might be even better.
Mm-hmm. Okay.
So there's always a trade-off that maybe is more evident in embedded systems between power and what you have to, between performance and what you have to do to get that performance.
Yeah, I mean, you could think of an imaging application where you have in a car your image, your camera takes some images, brings them to the car, you get processed, and then the decision is taken whether to go to the left or the right.
Right.
And then, but the car has a limited amount of power, so you want to try to be as not use as much as possible. So you have a trade-off between power usage and speed.
Yeah. Well, I mean, in a car you have more power, but it would even be worse when you have things that are more remote and embedded and battery powered and things like that. Or then power becomes much more critical when you're working off a battery.
So there you see the power and the performance
trade-offs.
Trade-off between the two.
Yep. Most definitely.
Okay, well, very interesting topics, Eric, and well, I hope you enjoyed the rest of the conference.
Thank you very much.
You're welcome.